Hi everyone, this is Mr. Richmond, and for this video we're going to have a look at your density without numbers Google Sheet, your assignment. But before we have a look at that assignment, let's take a look at your PowerPoint notes, which cover density as a physical property. And how we define it is the measure of how many atoms are in an enclosed area. The closer together those atoms are, we consider the object to be more dense or greater density. Another way to think of it is it's a ratio, really. Density is just a ratio of how much stuff, matter, is compared to how much space that object is taking up, how much volume it has. We know the definition for mass. It's how much particles, how many atoms, how much stuff, how much matter does that object have, and we know what volume is. That's just the amount of space an object takes up. So let's look at our next slide. I've got a couple examples for you, which we'll probably do in class, so let's not get to that right now. Let's get to your Google Doc assignment, which looks like this. So mass, volume, and density without numbers. I'm not going to go over too many examples here, but you just should take note that all these boxes tend to have some different volumes. There might be some that are very similar, if not exact the same. I think that's actually a question for you, is which two boxes have the exact same volume? And what they're looking for here is what boxes have the exact same shape and size. And then mass, if you are getting asked questions about how much mass an object has, you just want to count how many dots are in that particular box. So that can be a little bit tricky because, again, most of the boxes have different shapes, different sizes. And again, we're looking at the ratio. So just because we have a box that's larger doesn't necessarily mean that it has to have greater density, or vice versa. Just because we have a box that's smaller doesn't mean that it has to have a lower density. So what's good to look at is if I take my drawing tool and if I cut an approximate section that's equivalent, regardless, and obviously this is an estimation, but I would say that these two boxes are pretty close to the same size. And now I can really tell that C has a greater density than F. How can I see that? Well, I'm taking the same volume, even though these two clearly have different shapes or different sizes. They have a different volume, but now that I'm looking at a specific sample size, it looks like I clearly have more dots. And then, again, because that density is the ratio of mass, or the amount of dots in this case, to volume, the amount of space something takes up, therefore we can conclude that C has a greater density, F has a less density, even though F has a larger volume compared to C. So I hope this gives you some idea of how to answer the remaining questions. The last question, you're going to have to draw certain boxes with different volumes or different masses. And if you have any questions, please come to class prepared to ask any of them. I hope this video was helpful for you, and good luck.